Hi, in this video, we'll continue to discuss some the technology of the Docker. Again, this video, this PDF I use from the Qian Yitang course, right? If you are interested in this course, you can contact their sales in their website. And to Google it, Qian Yitang, and you will get a website, and you can contact their sales to register for new class, to learn some new course there. Okay, and we will continue. And you may know that one of the container, the benefit is the container can easily to migrate between different OS. When I talk about OS, especially I refer to the Linux, right? I believe today world majority application, the OS should be the Linux. But Linux has a different version, right? Some is CentOS, some is Ubuntu, and the other one is Loki or something else, right? Different OS. The kernel is the same, but the library or distribution or some middleware is totally different, right? With the container, it'll be much easier because container just as long as you share the same old kernel, right? CentOS is Ubuntu, the old kernel is the same. They all Linux, right? So as long as the kernel is shared, then you can just migrate one container from one host to the other host. The reason still be the same. Container is equal to application plus environment. They already encapsulate everything inside the container, so they only rely the kernel to run. So that's why they can easily for the migration. So here the example, right? Like here is the developer environment. Here's the production environment. Just give you an example, right? In the developer environment, you can go to your Docker file folder, then use build command to build the image, then running the container from the image, right? Then you can get a result like here, right? You can get a hello world result. Then after all testing is okay, then you begin to push your image from locally to remote repository. Either go to public like a Docker Hub, or you go to your company's private repository like your Harbor, right? Harbor is the most famous one. So you can use Docker login and input your username password, then push the image. Then every image has a name, right? Later I will explain why the name usually should go to this one. Username, then backslash, then the image name. Later I will explain for this format, right? So now you push it to Docker Hub. Then production, you can just download it, right? Use pull to download it to a special production host. Then use the same command, docker run, then you can get the same result, right? So here is a beautiful thing. You don't care about the environment or the different Linux distribution, right? As long as the container image is same, you always get the same exact same result. So this is very important. If you work in some company, you should know the painful currently between the development team and the operation team, right? The reason is the every host, you can see there's so many different choices, right? You can public cloud, private cloud, and different OS, right? Different version, even for the CentOS, some CentOS 8 and CentOS 9, right? You may know what I mean, right? Some application running good in S8, but doesn't guarantee. In most chance, I can say you fail in a CentOS 9, right? Also, different middleware, right? Even for the database, different version. So many choice. It's impossible to let the application be very smoothly without any change, migrate from your development environment to your production environment, right? So it'll be a very big challenge for the DevOps layer. Then we go from the container. What's the beautiful thing of a container? Because actually only when this one container be really used in our real life, then DevOps can go to DevOps can be realistic and also be popular recently. Again, this container technology, they just combine your code and the environment, not only code, okay? So first of all, they can be isolated, right? One container crash, it's just the environment for this special code crash. You're not impacting the other one. So it's for secure, right? It's for the robust, right? The second thing is you can easily migrate one container from one host to the other host, no matter care about the different distribution or different module anymore, because you are not relying on the host environment. You are relying on the environment inside your container right now. So you doesn't care about underlay, what kind of they are running. As long as the same kernel, they should be okay, right? So with this container technology, DevOps will become much easier, right? You can think about if we don't have we don't have a container, right? Then DevOps will be very complex and also not be possible actually when you go to some very complex project, right? For example, your developers team create a new program, right? Then if you didn't use a container, then DevOps need to go to the production environment, find out different of environment. There's so many things like OS different, database difference, library difference, right? Then the script need to help you to fix all of them before you can really put the code to production. It's not impossible, but you can think about it too complex, right? And always result in fail. So it's very hard for DevOps without container technology. But now with the container technology, later I can show you the CI/CD process. It'll be very much easier because you don't care about the underlay environment anymore. The container already has some overlay environment inside the container itself. So DevOps, only thing just need to have you to push, like this one, push to Docker Hub, then download it, then run it. That's it. Actually, here already just give you some idea how can you run a DevOps script. Just need to, in the much simpler way, just need two commands, pull and run. But for sure, here just some example, right? In the real life, it should not be so simple, but key concept is set. Just two behavior. That's it. You can finish DevOps, right? So that's why DevOps concept already been there over a decade, but only one recently. I cannot say recently, in the past 5 years maybe, when container become more and more popular, then DevOps become more and more doable in some big company, in some complex project. That's why DevOps recently is also very, very popular right now. Right here, just give you example, CI/CD. Later, we have some dedicated course, dedicated slide for the CI/CD, right? Like build, continue test, continue deploy, then go back to upgrade to the new version, right? There's so many different choice, right? So that's why container is coming true. It's so helpful, help you to handle so many complex situations of DevOps, right? So first of all, container make it easy between the development team and the operation team, right? Development team just develop their app, their code, then encapsulation everything, the code and environment into a container, then ship the container to operation. Operation just put it on the physical host, bring on it, that's it. So much easier. Everything is so simple with the container kicking. Okay, so only with this container technology, then DevOps begin to be doable with some big company. Okay, now just some high level introduction, right? Later when we go to the more detailed part, you may get more and more clear picture of what I'm saying right now. So sometimes you can think about this container just like some app in your uh, phone, like Android phone, right? In the Android phone, the developer just to build the APK, then publish in some like a Play Store, some application store. Then your customer download the APK, then begin to run, right? So everything is similar like container. Container is also developer generate the source code, then use the container technology to build the source code and the environment, then publish it to the Docker Hub or your private the repository. Then the other end just need to download it and run it right away, right? So everything is similar here. So sometimes you can compare with the think about the container, right? If you think about if you have container support, it's just like a smartphone, right? Like the Android or the iPhone, right? If you don't have container support, then just a decade ago, right? So everything just like a function phone. You know the function phone, right? It's you can only function for the like a phone call, but cannot do anything application layer. So this is just compare, okay? But maybe you can get some idea what I mean. You can compare the how you install application in your phone and compare with the how you just in the production environment, how can you just quickly bring out services, right? So here is a diagram to show you. This is to be famous, right? Always you can see container just like a wheel. There is a container, a lot of container on top of the wheel, right? This wheel you can think about is a kernel, right? It's a kernel set, like I say. All the Linux kernel, no matter CentOS or the Ubuntu, they always best same, right? Different is the container application, right? But this container include the environment, not only the code. Environment is important. So that's why when the application running, you rely on the environment inside container, not in the physical. Physical host also has their own environment, their own library, but it cannot be used by the container. Okay, and so that's why the different container isolated to each other, right, to be more safe, but they share the same OS kernel layer. Now talk about container. Container has different, just like in our real life, the same function always has different vendor, right? So container is almost the same. We have Docker container, also like container.id maybe, I'm not sure. But Docker is the most famous one. But here is one thing is that because later we will continue to learn some Kubernetes, right? But Kubernetes with the latest version, they will not support the Docker runtime anymore, right? But you can still use Docker to build an image for sure. Later I will explain what's the detail there. But now, because this course is about Docker, so again, Docker today is still most popular container builder layer. Most of the containers still built by Docker or in Docker format layer, right? So we use the Docker, select Docker to introduce the whole container course. So here, first of all, Docker is a company, right? So you can log into the docker.com to download this Docker engine. Like I say, container is running on top of the Docker engine layer, right? And Docker company released two kind of version engine. One is called CE version. The other called Enterprise EE version. C is free. You can always to download it, right? And usually this Docker engine is based on the Linux, right? But now if you host is Windows, you can also run Docker, but you need a special VM to help you to achieve that. But in our course, we also focus on the host is Linux itself, so to avoid this complex, right? Docker is built by, this is the history, how the Docker be invented, and what's in history, what kind of milestone happened in the past years. And Docker is use Go to Go is invented by Google, right? So it's a program to develop the whole Docker engine layer. So here's the comparison between the Docker and the container. I can say container is also Docker. Container is this concept. Docker is just a vendor, just like in network, Cisco and Juniper, right? Docker is a vendor actually. So here's the compare between the container and the VM, right? So performance compare, okay? So when you power on the container, just seconds, you can bring out container right away. It's very quickly. But for the VM, need minutes, right? You need to power on the VM OS itself. Then OS will bring out its own application. Take a long time, 5 minutes, 10 minutes, you can say, right? And also for the hardware, for the hard disk, right? Container, like I say, they share the same kernel. So in the container itself, you no need to include anything related to the OS kernel. So you can save a lot. Also, container usually for some special application, only to install this library for this special application. So hard disk should be used very, very minimal. But for VM, you need to include all the popular library, because you never know what kind of application may run on top of your VM. So maybe it's GB for hard disk, right? A lot, right? And for VM, you need to dedicate running called guest OS on top of the host OS, right? Then you run your application on top of the your guest OS. So the performance point of view, you can see different layer, right? Too many layer is result in the weak the performance. So the performance is not good. But for container, just need to go through some Docker engine. So you'll be very, very quick. Very, very similar like performance of services, right? So the performance is much better than VM. So that's why resulting for one host usually can run 10, maybe 20 VM, but in the same time, the same host can run thousands of containers. Like I say, you should compare the container as the services, right? You can run a lot of services in the same single bare metal host, right? A lot of services like the DNS, NTP, everything is a services, right? So you can, if we change it to a container, the cost almost be zero, right? So how many services you can run in one single host, then you can run, then you can get almost the same number. How many container you can run one on a single host layer, right? So here we already discussed for this part. So I now cover this again. How can you compare? Why we need a container, right? Why currently there's a big trend migrate from VM to container, because the benefits I just introduced, right? So let's go to some container the core concept, right? Container has some, I can say 3, right? Image, container, repository, right? So image, just like OVA, in the VM, you know the OVA file, right? You can build, especially when some application, they build a special image, they can begin to distribute or save to the repository. And the other people just download it and run it. So that's an image. An image usually be read only. You can read and bring a container based on the image, but you should no need to change it. So that's why it's read only. And container just like a VM itself, right? One VM, multiple VM can come from same OVA, so the concept here is the same. The multiple container can come from the same image, and container itself you can read and write, right? You can be power on, pause, and delete. Each container is isolated to each other, right? So each container, when they run, they share the R part, read-only part. But in the meantime, they also have some read and write layer. Later, I can explain more detail about layer concept of the container, right? And now the third thing is the repository, right? When you publish one image, you need to push to the repository. Repository has two. One is the public one, like a Docker Hub. The other is you can build your own inside your company, which should be Harbor. For sure, the other solution, but Harbor is much more popular. Okay, so yeah, I think that's it. That's it for this the whole the first part. The second part will go to how to installation. Okay, see you later.